Good morning. Thank you for joining us. I'm Jeff Puma. I'm Content Director for the Manufacturing Leadership Council, and I'm excited to have you here today for our first of the Automation and Operational Excellence Decision Compass group calls of the year. This is a combined group of the old Automation Consortium and the OpEx Decision Compass group. We've brought these things together. We are going to be having more meetings than the other DC groups this year in order to make sure that we're able to service both of that automation and operational excellence um, uh, audience. Meanwhile, we all know that automation and operational excellence have come closer together, and so we thought there was a good synergy, and so that's why we have moved in this direction. Today, we're going to be talking about autonomous optimization in manufacturing. Here is our overall agenda, and I know when I hand it off to Maurice O'Brien later, he's going to go through and actually speak about his own agenda for his portion of the meeting and the presentation. But overall, here's what we got. We're going to talk through some MLC announcements. I'll hand it over to Maurice, and then we'll have Q&A and wrap up. In the interim, if you could have your camera off and your microphone muted, that will help us get a clean recording. You can put questions into the chat throughout, and Maurice will take pauses during his presentation to answer questions. And if we don't get to something there, we'll have that Q&A session at the end, and then we'll wrap up and we'll go from there. So first on the announcement front, as you are most likely aware, Rethink is coming up June 15th through 18th. We are very excited about the program that we've assembled. We have some of the best keynotes and presentations and case studies that we've ever had. Last year we celebrated our 20th anniversary, and so as we head into our third decade, we're very excited for the strong program with folks from the Hershey Company and Siemens and Rockwell Calypso and Eaton and Goldman Sachs, and kind of the whole gamut of digital transformation and different perspectives. And it's a don't miss opportunity to network, to hear from leaders, and to take away actionable ideas and content that you can use in your organization. Prior to Rethink, we will be having a tour at Schneider Electric in Monterrey, Mexico at the end of April. I'll note that the links for both Rethink and the Schneider Electric tour are in the chat right now, so you can click on those, or you can use the QR code that you see on your screen. And then save the date for the United Scrap Metal Tour, which will be happening right outside of Chicago, August 12th through 13th. And so that Schneider tour, I believe there are only less than 20 spots still available. So if you want to participate in that, you're going to want to register for that as soon as we get off this call. Speaking of things that you might want to do right after we get off this call, we have a survey in the field right now. This is our supply chain survey. It is the first time we have fielded the survey since 2023. We know that things have changed. You can see the link to that survey right in the chat, or you likely got an email in your inbox that also has that link, or this QR code on screen. Take a moment, fill out that survey. It helps us get original research that we publish in the Manufacturing Leadership Journal, but it also is used when we go out and spread the gospel of digital transformation in presentations. It finds its way into the speakers that we align with and bring in for things like the Future of Manufacturing Project, master classes, DC groups, and of course, Rethink. As I mentioned, on the DC front, we have 4 groups now for our DC calls. I know since this is our first one of this group, I want to kind of go through this so everyone is aware. Automation and operational excellence, which is this call today. Sustainability and circular economy, which will have a call next Thursday, or its next call on Thursday. The data mastery and governance and analytics group, which will be meeting on March 27th. and then the resilient supply networks and ecosystems, which has its next call on April 24th. So those are the 4 decision compass groups that we have this year, all aligned to the critical issues. In this group in particular, we have 6 meetings, and we have more than 6 topics that we'll be talking about throughout this year. We already have some of the speakers lined up for some of these presentations and those dates locked in. But if there's anything that you see on your screen now that you're like, oh, I'm an expert on this, I have experience on it, I have a case study, I have something that we're doing that I'd like to lead a discussion, you can find that. But you can reach out to me at jpuma@nam.org or David Van Engel, who you can also message through the chat as well. Here are the dates for our calls for this group. So our next one is March 20th, vision systems strategy considerations. And you see in the chat a link to register for that. And here are the details of that call. I'll bring this up again at the end of this call so that you can take a moment to register and get that on your calendar for that March 20th call. We're excited to have Clarios presenting on this vision systems topic. But today, I'm excited to have Maurice O'Brien here, and Maurice will be going through his presentation. I'm going to stop my screen share and let him kind of come on with his screen and his share now. Before I do that, or as I'm doing that, I just want to remind you that that you can put questions into chat, and we'll get to that either during the call or at the end during the Q&A session. But Maurice Brien, glad to have you here, and looking forward to your presentation. So take it away.
Well, first of all, thank you, Jeff, and the Manufacturing Leadership Council for the opportunity to present today. Second comment would be good job, Jeff, on the Irish pronunciation of my name. Some people have pronounce it more Maurice, but excellent job. It actually is Maurice O'Brien. So my background, I have been with Analog Devices for almost 23 years, based in Limerick in Ireland. Over those 23 years, I've worked in various roles. I worked in more product-centric roles where I worked on specific technologies like power management or connectivity solutions. And more recently, over the last 5 or 6 years, I am part of our industrial automation strategy. So in my current role, I have global responsibility for Analog Devices industrial automation strategy. So what does that mean? Ultimately, I work with our customers, but also our customers' customers. So again, I work across that manufacturing ecosystem with automation equipment vendors, machine builders, system integrators, and automation managers within factory and manufacturing environments to understand what the challenges, opportunities drive back into Analog Devices, into our product teams, what roadmaps and what technologies that we should be investing in to deliver the future of manufacturing. So in terms of the agenda, brief introduction to Analog Devices. I'm sure not everybody will be aware of who and what Analog Devices are. We'll talk a little bit about the industrial manufacturing challenges as I see them. Talk about the transformation of industrial manufacturing. It's an exciting time, huge change, huge new technologies, huge opportunities to drive automation. Whereas before we would have really focused on sustainability in manufacturing, I think, I'm going to talk about a more holistic way of looking around resource-aware manufacturing. We're going to focus in on the key topic today, which is autonomous optimization in manufacturing, what the future trends are, what technologies are coming through. I think any of these calls, we have to talk about AI and where it could play. So I'll talk a little bit about where ADI fits in, what we call edge AI, or AI located close to the sensor and actuator. And then finally, we'll just kind of summarize and talk about the need for collaboration to accelerate innovation. So there are a couple of natural pauses. So I will certainly pause, and if there's any questions, that's the opportunity. And equally, again, as Jeff said, feel free to put some questions into the chat, and hopefully at the end, we'll come back around to them. So briefly, just regards Analog Devices. So Analog Devices, headquartered in Boston, Massachusetts. So we were founded back in 1965. So we are a leader in analog, digital, and software solutions. In 2024, our revenue is about $9.4 billion. I think what's interesting to look at in the pie chart is how much we are aligned with the industrial end market. Almost 50% of our revenue comes from the industrial end market. On the right-hand side, it just talks about the various areas. So ADI plays across all areas. So from renewable energy, connected humanity, sustainable automotive, industrial automation is where I sit. We also service advanced digital healthcare and immersive consumer experience. So as you'll see on the next slide, we have quite a broad reach. As analog devices, we have 75,000 product SKUs. We have over 100,000 customers. From a technology perspective, we talk about how we bridge the analog and digital world, or the physical and digital world. We live in a physical analog world. We have to interact with things and move things and sense things. So as you can see along the bottom, our core technologies around sensing, measurement, compute, connect, and power. We consider ourselves a very innovative company. We spend about $1.5 billion of R&D every year. So we're spending about 16% of our total revenue every year back into R&D. Huge amount of patents, significant capital investment in terms of our own factories, and about 24,000 employees. I think what's kind of great about ADI, and certainly in my job, is that analog devices is not just a semiconductor provider in terms of technology. We are also a manufacturing company. So we have a global manufacturing footprint. We own and operate 11 manufacturing facilities across the world. We run what we call a hybrid manufacturing strategy. So our higher feature, larger process nodes, we have our own internal wafer fabrications. So here where I am in Limerick, Ireland, we have a wafer fab here on site. We also have a wafer fab in Wilmington, Massachusetts, and we have one in Washington in Camas, and a large facility in Oregon. And we as ADI have our own automation journey, particularly in our front-end wafer fabrication. In our wafer fabs, we have lots of skilled operatives within those fabs, operating in a clean room environment, and they're carrying wafer cassettes from one end of the fab to the other. They're loading wafer cassettes in and out of various tools. There's actually a huge amount of walking involved in all this. And we ourselves are embracing advanced automation and are looking to deploy autonomous automation in our own facilities. We're installing overhead wafer conveyor systems so that we can move the wafer cassettes seamlessly around and store them. We're also looking at advanced robotics. We're looking to see how we can use mobile robots within the wafer fab to take those wafer cassettes out of a vertical elevator, move them to the machine tool, and even open the machine tool, insert them, take them back out. So again, I think it's good to reinforce that we see both sides. Again, the technology provider, but also we are the user of advanced automation. So again, as I mentioned at the start, in terms of my role, I spend a lot of time out visiting customers globally. I spend a lot of time also, working as also with the Manufacturing Leadership Council, sitting in meetings or doing factory tours and talking with, I guess, ultimately peers like you, like the people on the call today that are running automation systems. So what I've tried to do is aggregate the feedback as I see it. So one of the challenges that I see as I talk to automation managers and I do factory tours is that, broadly speaking, we have a lot of brownfield factories where we're looking to deploy more advanced automation. And as I walk around these factories, one of the challenges is interoperability around data. We end up having a lot of data islands. So sometimes I'll do a factory tour and there'll be one cell that's highly automated. They were able to really justify ROI, and they've being able to move skilled workers onto more higher value roles, and they've deployed a huge amount of automation, advanced robots, really, really well automated. But then I can take 5 paces further, and it's still a metal press, or it's an extrusion machine. It's a piece of equipment that's 40 years old, and there's no access to any data off it. And that's what I mean about that interoperability of data, getting the data from all the various pieces of equipment across the manufacturing floor and getting more access to that data. The second one I would talk about is validation time. There's definitely a move in a lot of manufacturing to support ever increasing product SKUs. And the challenge then around setting up new manufacturing flows or rekitting an existing for a different product SKU, the validation time to validate that line can be quite onerous. That then has the knock-on effect of declining OEE or operating obviously equipment effectiveness. So that is becoming even more challenged as we look to embrace and support increasing product SKUs. In many, many areas, the ability to hire skilled workforce is a challenge. I would say the same in terms of analog devices, working 12-hour shift in a wafer fab in that type of clean room environment, it's not as easy as it might have been in the past to acquire and hire that talent. So again, we need more automation to alleviate and help solve that challenge. And then finally, there's capacity constraints. So again, as I walk around and talk with automation managers, it's not necessarily that they're building new factories or they're extending their existing footprint. There's a big challenge to get more out of the existing footprint, to drive more productivity and get more support for increasing product SKUs within the existing fabric of the factory. And again, to solve that, again, we're looking at more advanced automation. So the other thing I would say is that automation and manufacturing, there's a lot of change. It's actually quite an exciting time. If we look at the challenges from a global economic and technology perspective, from a global perspective, we have all the challenges around sustainability, reshoring. From an economic perspective, then we've got post-COVID, all these challenges around supply resiliency. We talked about labor shortages, and there is capacity and I would say capital constraints. Again, in my perspective, I would say the days of building a big new factory and producing one or two products for 20 years is kind of gone. I mean, product life cycles are reducing, product variants are ever increasing, but again, there's more of a focus on how do we get more out of our existing footprints. From a technology perspective, then, there's huge amounts of new technologies that are being developed that can be deployed to solve some of these challenges. So I'll talk a little bit around sensor fusion. How can we sensorize our manufacturing equipment to extract more data on how it's operating to figure out how we can drive OEE, how we can enable more software-defined automation to enable more flexible manufacturing, and how AI will enable more autonomous manufacturing. So from my perspective, we would talk a lot about, sustainable manufacturing. And I think what I've tried to do and how I present, automation opportunities from my perspective is I've tried to take a step back and talk about resource-aware manufacturing. So what do I mean by that? So ultimately, there are 4 resources. There's capital, power, material, and human. So no matter what automation project it is, there's still an ROI. You still have to go to your CTO and get the check signed, and there's going to be a 3-year ROI or a 5-year ROI, to justify that investment. So we have to demonstrate and show capital efficiency from that investment. There is power efficiency. Energy is not as cheap as it used to be. We all want to reduce energy consumption for more sustainable manufacturing. How can we use less energy while still increasing productivity? How can we do more adaptive closed loop or peak load management, running, for example, very energy intensive applications like heating water at nighttime when electricity is cheaper than maybe during the day. Material efficiency. Obviously, the other side of ESG is not just energy consumption, but reducing material waste. So again, how can we sensorize machines to ensure that if we're changing from one product SKU to another, that we're not having to flush the line or having rejects where we have a lot of material waste? How can we move towards zero reject production? And then finally, human efficiency. How do we effectively and more efficiently use human operative staff within our manufacturing organizations? How can we move away from some of the more labor-intensive tasks that can be automated and then free up that human efficiency, more higher value tasks? So, for example, how can we deploy more collaborative robots that can do some of the heavy lifting and then enable more productivity from the operator perspective? But what I would say is we look across all of these four areas, data is the foundation. I mean, we need the data to try and drive some of these activities. And in order to maximize our operations and drive a lot of this resource-aware manufacturing, everything comes from data. So I'm just going to pause there again. I'm going to go in a little bit more details on what do I mean by resource-aware manufacturing, and particularly what do I mean by autonomous optimization of manufacturing. But again, I'll just give that moment for a pause. If there's any questions, I will happily take them now. Or again, if there's any questions, feel free to put them in the chat. Okay, so autonomous optimization of manufacturing. What exactly do I mean? So what I'm looking at here is this future trend where, from a manufacturing and automation perspective, we're trying to enable more real-time optimization. We're trying to put more intelligence in at the equipment level so that we can enable more kind of self-aware and self-awareness of what is required in a manufacturing flow. Like the ideal use case would be, as the machine sees a change in the input materials to that stage, it's able to reconfigure itself automatically. Or another example would be where a packaging machine. So a packaging machine can package 6, 12, or 24 bottles. So traditionally, what would happen is you would need a skilled operative to come between each product SKU and would twist all the dials to change the cutting blade and the cutting angle and rekit it to go from 6 to 12. Why could we not just replace those manual levers with high torque stepper motors, have it all under PLC control? And a task that might have taken 1 or 2 hours for an operator to reconfigure that packaging machine could be done under PLC control in, probably 1 or 2 minutes. That, I think the packaging machine is a good example. As we look to drive more OEE and more data, we need more real-world data, and we would consider that more sensor fusion. How do we deploy more sensing on the machines to get a better understanding of, how they're operating? So we may look at a vibration signature, we may look at humidity or temperature or displacement, but ultimately use that data to drive future AI use cases that can, help optimize OEE. We talked about agile manufacturing and the need to support increasing product SKUs. As we look to connect more of these manufacturing assets, we need to have increased cybersecurity. So security, hardened control, and connectivity. Other areas then, obviously energy efficiency. We want autonomous optimization to enable more energy efficiency in manufacturing. We're ultimately looking to drive OEE as part of this to drive productivity, quality control, obviously ensuring the highest levels of quality, trying to reduce any material waste. And then finally, for all the autonomous manufacturing we want to deploy, we have to ensure a safe working environment for the employees who ultimately will be working alongside this advanced automation. So if we are going to re-engineer systems for autonomous optimization and manufacturing, what does that mean? So again, just a brief pause. If there's any questions so far, happy to take them, or if not, we can keep going.
Maurice, there's actually one in the chat.
Yeah.
Why is OEE declining? Is the question.
Okay, so my example here is that as we are looking to support increasing product SKUs, we have to spend more time setting up the machine from one product SKU to the next product SKU. So that's ultimately putting more pressure on that kind of overall OEE in terms of that, productivity or effectiveness of that machine. It's just putting more challenges as we look to support that increasing product SKU. So obviously from a kind of a technology perspective, there are many, many products. So the way I try to talk about, let's say, ADI's capabilities or ADI's vision, I'm going to look at it through the lens of connect, control, and interpret. And we'll take one slide on each of the 3Ds and talk a little bit about where technology can help advance this overall vision of autonomous optimization. So again, as I mentioned, when I walk around lots of manufacturing environments, we have a hybrid of kind of advanced automation and more legacy automation. And one of the key goals around advanced automation is more transparent access to data off of all the various manufacturing equipment. So we need to have seamless connectivity across the various manufacturing cells and within the manufacturing cells across the equipment with a view to driving more continuous process improvements through using that data to drive that improvement. As we look to drive more, we'll say more flexibility, we need to push more of the control down. So we're looking to enable more decentralized autonomous control. And we'll talk a little bit more about how we're trying to bring some of the control function from the PLC and bring it down to the equipment level. And in the third example we will talk about is, again, in order to try and drive or increase the OEE, how can we deploy, again, more sensors on the machines to try and help give us the insight as to why we're seeing a variation from maybe one manufacturing line to another. So in terms of the connect strategy, so again, transparent access to data. So we have a huge range of connectivity solutions, that are available today. And ultimately, where we see the future from a connectivity perspective is ultimately a hybrid between wired and wireless connectivity. So often on the control level, in terms of the connectivity between the various physical assets, we see a move towards industrial Ethernet. It has the advantage of scalable bandwidth. You can do 10, 100 gigabit, multi-gigabit with Ethernet, and you get all the benefits of an IEEE standard and the guaranteed interoperability that comes with being an Ethernet standard. But on top of that, we also need protocols, or we need to be able to deliver more deterministic real-time Ethernet control. Again, the example we gave, Ethernet in the home, I'm watching Netflix and it buffers for a while because my kids are watching something else on Netflix. When we're in an industrial environment, if we send a control signal, that control signal must go and must happen within a very narrow period of time. So to make industrial Ethernet robust and deterministic in real time, we have to deploy real-time protocols. And time-sensitive networking, or TSN, is a mechanism where on a single Ethernet network, we can share non-real-time data like vision data, but also we can share control data on the same network and have that guaranteed real-time control traffic from a deterministic perspective. In applications where we have to serve longer connectivity. So again, process industry, we've got a process installation that is kilometers square in terms of size. So we have, other Ethernet technologies that are supporting longer distances like 10BASE-T1L or Ethernet APL, which can be used in intrinsically safe applications, so explosive environments. In traditional, more factory automation, we've got I/O link for more simple light curtains and actuators. And I think what we're seeing to complement that wired capability is the opportunities around wireless and private 5G networks. So for example, as we look to deploy more AMRs in our manufacturing facilities, 5G gives us the advantage of obviously connectivity in a mobile environment. We may have some sensors or actuators that are relatively remote that again could benefit from a wireless connectivity. But again, ultimately, as we take a step back, we see this hybrid connectivity as the future, where we both support wired, normally in terms of that control, and then the wireless in terms of mobile applications are more remote, more difficult to access. But again, whatever the connectivity solution is, ultimately, what we're trying to do is make sure that all of the assets within the factory ideally are on some form of network where we can start to pull data back from them with a view to using that data to drive productivity improvements. So the second part of the lens was around control. So what we're looking at here is how can we move more control from that centralized PLC and move it down closer and ideally down to the equipment level. So the example I would give here is I have a manufacturing line and I have a centralized PLC, and let's say I have 10 pieces of equipment and they're all controlled by that single PLC. And we talked about the need to support increasing product skews and let's say drive overall OEE. So for example, we may want to sensorize one or more of those pieces of equipment to try and see if we can understand some of the subtleties, because ultimately maybe I have two lines running, they're both making the same both making the same product using the same equipment, but this line is running at 90% OEE and this line is running at 85% OEE. Why? What's that subtle difference? So we might decide that we're going to put some vibration sensors on, some temperature sensors, maybe some humidity sensors. We're going to try and see, is there a subtle difference in these two lines to try and get them both up to 90%. The challenge there would be often, if all of that manufacturing line is under a single PLC, if I come along and I want to add some sensors to one of the pieces of equipment, often the challenge is, well, now I have to go ring my system integrator. I got to bring them on site. They have to go change, the code in the PLC. And then I'm back with, if I'm in a more regulated environment, I'm back to, quite a significant validation of that activity or of that manufacturing line, just to do maybe some simple reconfiguration or adding some simple sensors to that. So part of the vision here is, if we could take more of that control from the PLC and push it down into the equipment. So again, this notion of more edge compute. So the advantage here would be that if we had more autonomous capability within each of those 10 pieces of equipment, then ultimately, from a product SKU perspective, if we need to change product SKU or rekit that manufacturing line, if each of these individual blocks were more modular, we would do a validation on each of the blocks individually, and then we would have a lighter validation of the line, because these would be proven modular blocks that are easy to move around. And then in the case of where I wanted to add a sensor or something to that individual piece of equipment, it would be much easier, because I only would have to, update the code on that piece of equipment. So we're looking to move a lot of the control from the PLC, put it down in the equipment to deliver more modular equipment that can be individually validated, that can be reconfigured for a different manufacturing flow, and have a much lighter overall validation effort. So we would describe this as this example of FMMS, which is more flexible modular manufacturing solutions, enabled by more decentralized and autonomous control at the equipment level. The third part of it then is around interpret. So again, this is just a little bit more of the example of, again, I have my two manufacturing lines, they're both producing the same product, or I have a facility in Limerick and I have another facility in somewhere in the US. And again, I'm seeing this variation. They're making the same product, largely using the same piece of equipment, but I've got 90% OEE or 85% OEE or 80% OEE. So how can we use sensors onto these, deployed onto the various manufacturing equipment to try and understand the subtle differences? So we might look at temperature, humidity, pressure, vibration, or acoustic. And then ultimately, this is one specific example where, again, we have some sort of in this case, maybe a CNC machine where we have a lot of motors in motion. So can we bring some of this kind of rich real world data back into that encoder and then use new connectivity solutions like single pair Ethernet, and ultimately bring back more of this real world physical phenomena sensing data back up to the motion control level or up to the cloud. And then in the future, we will see AI being deployed, maybe in the case of a neural accelerator, that will use this real world data to help drive this continuous process improvement by understanding what maybe are the subtle changes on the various manufacturing lines. If it's an injection molding equipment, and looking at the displacement, looking at the humidity, looking at the vibration signatures to try and understand how can we increase that overall OEE by tweaking or, understanding better the subtleties at the machine level. So from an analog devices perspective, as we look at autonomous manufacturing systems, again, from our technology perspective, we're developing not just IC level solutions, but I wanted to highlight along the bottom that we also provide subsystems, be it wireless contactors for connectivity of a robotic end effector, or gripper control solutions, vibration monitoring solutions, in the case of maybe robotics, object detection, and machine learning solutions. So, we are providing either the fundamental technology, or in some cases subsystems for more robot modules, real-time configurability in terms of the actuation, delivering more power efficient solutions. And in the future, again, how can we use advanced sensing and IA to drive that overall autonomous manufacturing flow? So again, I'll just pause there again, Jeff. Just if there's any questions, happy to take them.
One just came in, actually.
Yep.
So it is, what is the main challenge in moving from a centralized PLC to edge device control? Thanks, Mark, for your question.
Yeah, that is a very good question. So what I would say is, like, here it is really working with that system integrator, whoever it is that you're working with, or the machine builder, in terms of how you interact with your, who's providing your technology. I think, like, one of the challenges I have in my role is that I believe a lot of the technology exists to solve a lot of what we described there. And one of the reasons why I, joined the Manufacturing Leadership Council and wanted to have this opportunity to interact and work with automation managers and leaders that are on this call and part of the Manufacturing Leadership Council is that part of my role is to try and show to the audience, to the people on this call, what capabilities, what technologies exist out there. And then ultimately, I need your help to work with your system integrators and your machine builders to start pulling and requesting that this is the future that you want. This is what you, I hope, are asking of your machine builders and system integrators, that you help me to drive that adoption. But largely speaking of what I presented today, and obviously AI is still more emerging, particularly on the control side, and we'll talk more about that. Again, the technology exists, but it's the pull from the automation managers within manufacturing that ultimately will accelerate the deployment of in this case, more decentralized control.
There's one other question in
Yep.
there, and that's, what's the impact of data collection, or sorry, what's the impact on data collection and interpretation when autonomous control is decentralized? Does it result in more data to be managed?
I think we might hopefully touch on this in my next section. So what I'm going to go on to next, and then we can come back again at the end if I don't touch on it, but I hope I will try and answer that in the next section. So again, what is the opportunity in terms of AI for autonomous optimization? So first of all, where can AI be located in manufacturing? So broadly speaking, there are three areas. One is at the sensor edge. So again, at the point of data generation. So that's what we call the edge, is the bridge, back to my original analogy of ADI, between the bridge between the physical and digital world. So there's opportunities at the sensor and actuator to deploy AI. There are opportunities to deploy AI at the point of aggregation. So an industrial PLC, DCS, maybe a motion controller, robot controller, etc. Where you've the first stage of aggregation, and then finally, and where most AI is being deployed currently, is either in the cloud or on-prem, in terms of that larger data aggregation. So from an ADI perspective, it's not for me to say which is best, or from an ADI perspective, where we can deliver more value is around how AI can be deployed at that sensor edge, or again, to the question, down at the equipment level. So this is actually a kind of a nice way of looking at when and why you might want to deploy AI at the edge. Again, the edge is at the point of actuation and sensing. So we may have applications where data bandwidth there may be data bandwidth limitations. So best example would be, I have a vibration monitor that's battery powered that I want to mount on a piece of equipment. So the advantage of AI at the edge, at this case, is that we're able to analyze the data physically on that end equipment, and we don't have to burn battery power pumping all this vibration data from the equipment up to the cloud. So again, it makes more sense if we could do that AI capability in terms of understanding let's say, the vibration signature literally on the device. We may have applications where latency is critical. So again, think of motion, robotic applications. We need to have much faster response times. So we don't have the ability to push the raw data up to the cloud, make an inference, and push it back down again. Again, there are, AI at the edge or at the point of actuation will give us that deterministic and real-time response that's required in a real-time application. From an economics perspective, connectivity costs money, pushing data up to the cloud, and obviously paying for, cloud-based AI. There's a cost there around connectivity and computational resources. So again, maybe some applications are better suited to having it at the edge. From a reliability perspective, once you're pushing data up into the cloud, there is a dependency on access to that connectivity, the robustness, the uptime of that connectivity. So again, in some cases, it may be a more robust, reliable solution to keep that data located closer to the point of actuation or sensing. And then finally, maybe this data is sensitive. Maybe we don't want it going either to a cloud that's external, or again, obviously some people will solve that with an on-site server. But again, from a privacy perspective, there may be applications where it's best for the data to stay, again, close to that point of acquisition. So again, it's, I'm just, I guess, talking through some specific use cases where we think AI could be used. And again, I think as we look to, again, well, what is the value of doing AI at the edge, at the point of acquisition, let's say in autonomous optimization of manufacturing? So the goal here is to enable proactive decision-making with real-world measurement modalities. Back to that sensor fusion example, using vibration, temperature sensing, with an outcome around reducing the need for a dependency on skilled labor, again, enabling that more personalized, complex manufacturing with the highest yields. So more specific examples. So again, we live in an analog, a physical world, and we have lots of sources of data. We've got industrial vision, temperature, pressure, force, inclination, position, be it rotational, angular, or multi-turn. So where we see the opportunity for this edge AI, and again, going back to our original question, I think, again, to enable more of this decentralized control at the equipment level, I think to really unlock and drive that from a productivity perspective, I think AI can really help us here. So example use cases. So in a mobile robot, perception, equally guided actuation. These are really good use cases that if you go back to my model of bandwidth, latency, privacy, that is well suited to having an AI capability that's literally maybe on the robot, and we're not trying to pump data back and forth and have that delay of that control loop. Another very important one, I think, in the future will be around defect or anomaly detection. So again, as I walk around various manufacturing facilities, a lot of the time there still is a huge amount of, human quality control, and people looking and making a judgment, and then somebody beside them making a judgment, and the challenges around, even a human interpretation of a defect versus anomaly. Huge opportunities for vision-based AI to try and help around quality control, defect anomaly detection. The example where we talked about sensor fusion and putting all these various sensing modalities onto the equipment and generating that real world data would be the example of that continuous process improvement, how we can drive the overall yield, or again, OEE of a particular manufacturing step. We can do that by sensorizing the equipment and then using AI at the edge, let's say to look at a vibration signature and to be able to identify maybe some anomalies that ultimately can be remedied to drive increased productivity. The other side of that, which is quite closely related, is the asset health prediction. So again, you'll all be familiar with condition-based monitoring and moving from a time-based maintenance strategy to more of a more of a condition based on the actual health of the asset. So again, nobody wants to be taking manufacturing lines down or equipment down to service it, unless it absolutely needs to. So again, opportunities around AI at the edge to look at the current state of health of a piece of asset or a motor, and then based on the actual data coming from that asset, knowing when to service it and ensuring that we are getting the most productivity and ultimately, in that case, the most uptime. Sensor fusion, I think we've covered a good bit. I think we talked a little bit about the pattern recognition again in terms of the anomaly detection. I think ultimately, and again, this is where I hopefully lean back in more on that question on the challenges around bringing the control from the PLC down into the equipment, is ultimately the end point for a lot of the AI at the edge use cases is, can we use AI as part of that control loop? Can we have AI as part of that sense, plan, and act loop, so that particularly as we look to enable more of that decentralized autonomous control, AI can really unlock a lot of the productivity gains associated with that. Again, I'll pause. We're almost at the end. Just a couple of slides just to kind of wrap it up. But again, Jeff, happy to take any questions.
There is a new one in there. And so wouldn't putting the control at the edge device pose a greater risk in terms of access points, as not all devices may have the proper security protocols to prevent malicious intrusions or cyber attacks?
Yes, I would say that is a very good question and an absolute challenge to this vision of seamless connectivity and having everything all, again, I talked at the start about a vision of having all of the assets in a manufacturing flow on a seamless connected Ethernet network. The opposite of that is I have just opened up my entire manufacturing facility to any malicious actor. That's there's both sides of that same coin. So absolutely, this vision around seamless connectivity and access to data across manufacturing cells and manufacturing lines has to be complemented and enabled through a very secure network and a huge amount of security. Again, I think in my earlier slide on the future requirements for autonomous optimization manufacturing, I talked about the need for security hardened control and secure, the importance of security. But ultimately, the only way we will unlock the benefits of Industry 4.0, digitization, all of the themes we all know we've either embraced or are about to embrace, can only be unlocked through more seamless connectivity to give us access to that data that we will use to drive those productivity improvements. But absolutely, security is a critical component of that vision for exactly the reason that question came from the audience. So finally, just to wrap up, collaborating to accelerate innovation. So again, huge opportunities in terms of technologies, significant challenges. But if we are to solve these challenges, so again, if we look at global in terms of sustainability, driving industrial efficiency, if we're going to solve some of these economic challenges around supply resiliency, labor shortages, if we want to enable more supply chain transparency or onshoring, if we want to, solve these challenges around faster innovation cycles, cybersecurity, as the last person pointed out, and this need to support ever-increasing product skews and more flexible manufacturing. Again, the technology largely exists, the capability for decentralized edge compute, secure connected systems, the future opportunities around AI-enabled software-defined automation. The good news is I'm talking to the converted here. We're all on this call for this very reason, because I think we all agree that being successful tomorrow requires a new approach, the importance of partnership, working together across the manufacturing ecosystem. So the silicon technology provider, which is, let's say, where ADI fits, the automation equipment vendors, the ABB, Siemens, Rockwell, Schneider of the world, the machine builders, the system integrators, and the people on this audience, the people who are responsible for delivering automation in manufacturing, coming together, working together. again, we have to figure out ways to accelerate the deployment of these technologies. How can we be more iterative, faster, flexible at proving out not just the capability of the technology, but the ROI. I'll go back to my earlier comment. All you guys on the call, I'm sure you see the opportunities to automate within your manufacturing facilities, but you still have to go and justify that ROI. So are there areas where we can work together for more rapid deployment and demonstrate how we can show those ROIs to justify those of its investments? And then, again, the MLC is a great vehicle for embracing these open ecosystems and how we can work together across that ecosystem. I just wanted to highlight, from an ADI perspective of how we are trying to do this. So this is an example of a collaboration we had at what we call our Catalyst Center here in Limerick. So we have a facility on site. It's 100,000 square feet where we use it to try out, test out new ideas. We've got a lot of space for deploying robots, 5G networks, some advanced battery monitoring solutions for automotive. So again, the list of all the areas that ADI play in. But I wanted to, give an example of where we as ADI are working across the ecosystem. We had a robotics event last year. And at that event, we brought together, some of the leading automation vendors, so people like SICK and Siemens, traditional automation vendors. We brought in some system integrators. We had some robotics people like Omron and Teradyne. But more importantly, we had a huge attendance from manufacturing facilities like Johnson Johnson, Lilly, Medtronic, Boston Scientific, Bosch, and Lam. So again, my comment here, I think, is to Jeff and to the Manufacturing Leadership Council, and to extend the invitation to the Manufacturing Leadership Council. If ever you have plans for an overseas event, we as Analog Devices would certainly love to host the Manufacturing Leadership Council in any ecosystem activities that could be held here in our Catalyst Center in Ireland. If the NFL and the Pittsburgh Steelers can come to Ireland to play American football, then I hope the Manufacturing Leadership Council can come to Ireland in the near future. And again, just a call out to the Manufacturing Leadership Council. Again, on the left-hand side is our vision around partnership, rapid deployment, open ecosystems. And certainly as the representative of Analog Devices on the Manufacturing Leadership Council, I'm really excited about the opportunity to work with the Manufacturing Leadership Council to, accelerate the adoption of the technology, hopefully impart in the audience the vision of and the capability that exists today. And I need your help to pull that capability, in through your automation deployments in whatever brownfield upgrade you might be doing, or maybe some future greenfield opportunities. Is from my perspective to try and paint that picture of what future capabilities exist, and ultimately, how can we work together to accelerate the factory of the future? So again, happy to take any questions. I think that's my last slide.
Excellent. Maurice, thank you so much for the presentation and the invitation. Hopefully we'll be able to take you up on that at some point. We have a few minutes left. If anyone has any other questions, you can feel free to actually come off mute and come on camera and ask it live if you would like. So let's take a pause and see if anybody would like to take us up on that.
And again, just while people are thinking about that, again, feel free to reach out to me on LinkedIn, connect, send me a message. Again, so yeah, I'm happy to have a subsequent discussion. Look, if there's something there that caught your eye, you'd like to learn more. Again, I can't talk to the detail of all of those capabilities, but what I can do is identify maybe a subject matter expert that's close to me that could go to the next level of detail on any of the topics I covered. So absolutely, feel free to reach out through Jeff or David. They can contact me, but again, or if there's any topics here that maybe we could go deeper on in a future session. I would try and bring in some more domain experts on my side that could, go to a more detailed level. I tried to cover quite a bit of topics here. I have to trade off the breadth versus the depth, but all I can say is if there's something of interest and you'd like to learn more, please reach out.
Don't see any questions coming in. So I think we're okay in that regard. So let me thank you again, Maurice, for the great conversation and for presenting on this important topic, and also, of course, for the invitation. Like I said, it's that would be wonderful. So we'll see if we can make that happen. I'm going to take back over the screen share here for a second, if I can. Let's see. Yep. Okay. So want to, as we kind of transition out of this conversation from the autonomous optimization in manufacturing, I just want to remind everyone that we'll be talking about vision systems and the strategy considerations that are important to that during our next call, which will be on March 20th. You'll see a QR code on the screen, and if you scroll back up in the chat, you'll see that link there as well. You can register for this now. We'll also, of course, be putting it in our Monday roll-up emails as well as in subsequent emails that you'll be getting. Oh, and I see David Van Engel just added it back into the chat. So thank you so much, Dave. We have a couple calls coming up. A couple more dates throughout the year. We'll have 4 more after that March 20th call. And of course, I want to do one last plug for the Schneider Electric Tour on April 28th and 29th in Monterrey, Mexico. Again, this one is almost completely sold out. So please, if you're interested in joining that, go to that QR code or click on the link in the chat, and or you can find it on our website under the events button, which is across the top of the website. You're going to want to register for this as soon as possible. Likewise, Rethink always sells out. We have probably our greatest lineup ever. I'd like to say that every year. I think that we get it a little bit better. And so this will be a phenomenal opportunity to network with peers, learn some new ideas, and take some things back that you can use right away in your operations. So don't hesitate to reach out to David Van Engel or Dan Witherington or me or anyone else at the MLC if you have questions about Rethink, about the tour, about upcoming DC groups. We are always excited to chat with our members and bring in new ideas and spread those out to our audience or answer any questions that you might have. So with that, my email address is on the screen in the bottom corner, jpuma@nam.org. If you do need to reach out, thank you again, Maurice, for the great presentation. And thanks to those who added some great questions into the chat. And we were excited to have everybody here today. And we'll see you again on March 20th. Thank you very much and have a wonderful day.